Morning, grade 7s. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all well today and looking forward to today's lesson. Just a reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to send me any feedback, suggestions, or any questions relating to the work we've covered, or perhaps there's a topic you'd like me to cover, and I'll be more than happy to do that going forward. Today we're going to look at 3D shapes, and in particular we're going to look at surface areas of 3D shapes and how to calculate those areas. On either side of that main theme we've got our warm-up, our mental arithmetic questions, and our brain bender to finish off on. Our warm-up activity for this morning is on the screen in front of you. There are some large numbers involved. Take your time when you work this out. Make sure you check your calculations. Tell me the value of each symbol and don't forget the question mark at the end. Right, good luck. So I actually started on the second line here. And I know that the two milk jugs are going to be equal to each other. And that those milk jugs multiplied together and then multiplied by 9 is going to give me 729. So I worked out 729 divided by 9. Okay. And then that gave me 81, all right? So I know that this milk jug multiplied by the second milk jug must give me 81, and I know that 9 times 9 is equal to 81, so that means that the second line is 9 times 9 times 9, and that's going to give me 81. I then went to the third line, and I know that 9 multiplied by 9 is 81. So therefore 81 multiplied by 2 must give me 162. Knowing that the corn is 2, I can go to the top line and I know that 2 multiplied by 2 multiplied by 2 is going to give me 8. Okay, so the barn is 8 and the corn is equal to 2. Now we've got 3 question marks to work out. The first one is 2 multiplied by 8 multiplied by 9. Okay, now what order you do this in is up to you, because remember, it doesn't matter the order in which you multiply, you're still going to get the same answer. So that's the commutative property of multiplication. So 2 times 8 is 16, and then 16 times 9 will be the same as 9 times 8, 72. 72 times 2 is 144. Or you could go 9 times 2 is 18, and 18 times 8 remains 144. Okay, and you'll see now that the next 2 questions are just a different order. Okay, but it still equals 144. So we're just trying to highlight the commutative property of multiplication to you. And then your last one is 9 times 8 times 2, and again that equals 144. Okay, guys, I hope you managed to work that out. We've been speaking about order of operations for a while now, and I know only multiplication is involved, but it's really important that you understand the concept of multiplying the numbers in any order to get the same answer. So you can make the calculations a lot easier for yourself. For me, the easiest calculation would have been the third one. The 9 times 8 is 72, and then 72 times 2 is 144. I just prefer doubling numbers rather than going 16 times 9 or 18 times 8. I think 72 times 2 would have been a lot easier. But again, it's up to you to decide and up to you to choose whatever you are comfortable with. Your 9 mental arithmetic questions are on the screen in front of you. Please take your time. Write everything down. Make sure you write things neatly, logically. Show all your calculations. Check your work. And let's see how you guys get on. Okay, question number 1 is 3,21. Add 15,8. All right. So I would suggest, or I would like to put a 0 after the 8, just so that we have the same amount of numbers after the decimal in both the top and the bottom number. Now I know that 1 plus 0 is 1, 2 plus 8 is 10, decimal lines up. 3, 5 is 8, plus the 1 is 9, and then I've got 19,01. Your checking strategy there is to perhaps subtract 15,8 from 19,01, and that should leave us with 3,21. And let's have a look if that is indeed the case. Okay, decimals line up, and there you have 3,21. So our answer must be correct. You could have subtracted 3,21 from 19,01, and then that should have given you an answer of 15,8. That's the second part of, or the second way to check that calculation. Question 2 is a subtraction question, and that is 13,271. Subtract 5,819, and I'm going to say it again. The columns that the numbers are in are vitally important, so make sure your tens are in line, your units are in line, your tenths, your hundredths, your thousandths, everything must be in line, and then we just subtract normally. We have to borrow wherever we need to. We must make sure that the decimals always line up, and then we should be left with an answer of 7,452. So 7 units, 4 tenths, 5 hundredths, 2 thousandths. And then remember the checking strategy is we do the inverse. So 2 plus 9 is 11, 5 and 1 is 6, 4 and 8 is 12, 7 and 5 is 12. Happy days, everything is correct. 56 multiplied by 15 is question number 3. There are multiple ways in which we can do multiplication sums. Today, I'm going to have a look at the split method. So I'm going to take 56 and split it up into 50 and 6. Okay, and then I'm going to take 15 and I'm going to split it up into 10 and 5. Now I know that 10 multiplied by 50 is 500. I know that 10 multiplied by 6 is 60. I know that 5 multiplied by 50 is 250. And I know that 5 multiplied by 6 is 30. Now it is just a case of adding. That's 750. That's 90. So if I add those together, I get 840. But let's have a look at another method to see if my 840 is indeed correct. Perhaps I've made a careless error. So as I've said to you guys many, many times before, it's really handy to always check your work. So 56 multiplied by 15. Let's try the double and half method. So if I double 15, I get 30. If I halve 56, I get 28. If I halve it again, I get 14 multiplied by 60. Now perhaps you can go 14 multiplied by 6. Okay, that's going to be 84. And then I need to add the multiple of 10. So that's going to give me 840. Okay, I could have actually gone one step further here and halved 14 to 7 multiplied by 120. Still would have given me 840. Okay, no problem. So if 2 different methods give me the same answer, I'm pretty confident that my calculations are indeed correct. Okay, long division next. And we know that long division can cause a few problems. And by now I'm sure you know that I like to do long division using multiplication. Okay. So the first thing I'm going to do is what's 24 multiplied by 100, and that's 2,400. Okay, I'm going to double that, so multiply it by 200. That's going to give me 4,800. All right, and now I can see how far am I away from 5,640. Well, I'm 840 away. So I'm going to first multiply by 50. Now that's going to be half of 2,400. So that's going to give me 1,200. Okay. And if I halve that and multiply by 25, I'm going to get 600. Okay. So now I can just put numbers together. So what I'm going to do is I'm going to put those two that I've underlined, 4,800 and 600 together, and that's going to give me 5,400. Okay? You can see from 5,400 to 5,640, I am 240 away. Okay? And you need to realize that 240 is 10 times 24. All right? So now all I need to do is I need to add the 200, the 25, and the 10, and that's going to give me 235. So my answer is going to be 235. But now we need to check it. Okay? And to check a division question, let's go and multiply the answer by 24. So 235 multiplied by 24, and I'm going to choose another multiplication method to use, and this is your standard column method. 5 times 4 is 20, carry the 2. 5 times 3 is 12, plus the 2 is 14, carry the 1. That's going to give me 9. Placeholder, 0, very important. 2 times 5 is 10, carry the 1. 2 times 3 is 6, plus the 1 is 7, and 2 times 2 is 4. Okay, from there, I just need to add. 0 and 0 is 4, 4 and 0, so 0, 0 is 0, 4 and 0 is 4, 9 and 7 is 6, and I need to add the 1, and that gives me 5,640, and we can clearly see that my 5,640 is repeated, so my original calculation must be correct. So go back and have a look at what I did when I multiplied 24 by 100, and then by 200, by 50, by 25, and then I recognized I still needed 10 groups of 24, and I put all those together. For me, it's a lot easier than doing a long algorithm that, to be quite honest, doesn't really make a lot of sense. Okay, the addition of fractions is next. And you guys need to recognize that the denominators are different. So the first thing I need to do is look for the lowest common denominator of 4 and 5. So if our question is 3/4 plus 1/5, my lowest common denominator of 4 and 5 is 20. 4 goes into 25 times, so 5 times 3 is 15. 5 goes into 24 times, so 4 times 1 is 4. And then I just add those two numbers together, and I get 19, and I keep the same denominator, which is 20. We are multiplying by 10 in question 6, and I'm pretty confident that you guys understand that when you multiply by 10, the number you're multiplying gets one place bigger. So it's 134,09 multiplied by 10. So that will become 1,340,9. Okay. 3/4 divided by 2. I'm going to change the 2 and make it 2/1, just so that I have two fractions. You know that the division sign changes to multiply, and that the second fraction gets inverted to its reciprocal. Okay, and then I multiply the numerators and I multiply the denominators, and I get 3/8. Notice that there's no diagonal cancelling out, because there are no numbers that actually cancel out with each other in the question. Question 8 is the multiplication of a mixed numeral. So that's a whole number and a fraction together, and that's going to be 2 1/4. And I need to multiply that by 4/5. So I'm going to convert to an improper fraction. That's 9/4. So 2 times 4 is 8, plus the 1 is 9, and I keep the original denominator. And now I can see, hang on, I can cancel those two 4's out, because 4 goes into 4. Okay, so now my numerator leaves me with 9 times 1 is 9, and the denominator 1 times 5 is 5. And if you needed to convert that to a mixed number, that's 1 4/5. Okay, great. Then the last question is 25% of 400. and 25% is equal to a quarter. So we're looking for a quarter of 400. Let's just write that down. That's equal to 25 over 100, which is equal to a quarter. So in essence, we're looking for a quarter of 200, and 200, sorry, not 200, 400. And 400 divided by 4 is going to give me 100. Alternatively, if you hadn't recognized that 25% is a quarter, that's not a problem. You could have found 10% of 400 equals 40. Therefore, 20% is double that, 18. If 10% is 40, then 5% is going to equal 20. And if I put 20% and 5% together, that's 20 and 80. And again, that gives me 100. Okay, guys, I hope you're working through these questions well and you're remembering the past taught principles. Let's go have a look at the main theme today, which is surface area of three-dimensional shapes. We're going to look at surface areas of three-dimensional shapes. And the first one we're going to look at is the surface area of a cuboid. Okay, so to find the surface area of a shape, we need to calculate the total area of all the faces. So we've looked at the difference between faces, vertices, and edges. And now we should be able to work out or remember that a cuboid has 6 faces. The top and the bottom of the cuboid have the same area, okay? And those are now highlighted to you in blue. And then those in purple are the same. And as well as those in green are going to be the same area. Okay, so now if I give you the dimensions of the cuboid, 7 centimeters high, 8 centimeters long, and 5 centimeters in width, then you should be able to work out the surface area of this cuboid. So I'm going to work through it with you, and then I'm going to give you a few to try on your own. So first of all, the top area is going to be 8 times 5. Okay, the length is 8, the width is 5. We know that the area of a rectangle is length times width, or length times breadth, and 8 times 5 is therefore equal to 40. We know that the area of the front face is going to be a length of 7 and a width of 5, and that's going to give us 35 centimeters squared. And then we know that the area of the side is going to be a length of 8 and a width of 7, and that's going to give us 56 centimeters squared. So now we've worked out the areas of 3 faces. We need to go ahead and double each face, because as we already identified, 2 faces are going to have an equal area. So we have 2 times 40 for the top and the bottom, 2 times 35 for the front and the back, and 2 times 56 for the left and the right side. And if we work all of that out, it's going to be 80 plus 70 plus 112. So your total surface area is going to be 262 centimeters squared. Remember, the unit must be in squared units, okay? Because we're working out the area. Okay, so we can find the formula for the surface area of a cuboid as follows. Okay, so there you've been given the height, the length, and the width. So we know that it's going to be 2 multiplied by the length and width. So that's for the top and the bottom. It's going to be 2 multiplied by the height and the width for the front and the back. And it's going to be 2 multiplied by the length and the height for the left and the right side. Just remember that where it says LW or HW or LH, that means length times width, or height times width, or length times height for the green section. And then all we need to do is add those values together, and that will give us the total surface area. So the next surface area is going to be of a cube. Okay, so how do we find the surface area of a cube when we're only given one length, and that's been indicated by the letter X? So the first thing to remember is that all six faces have a cube, all six faces of a cube have the same area. So remember, a cube is the three-dimensional version of a square. And we know that a square, all sides are equal, okay? And in a cube, all faces are the same. So all we need to do is work out the area of one face, okay? And that's going to be x multiplied by x, okay? And then we need to multiply that by 6, okay? And that's going to give us 6x squared. Okay, so I'm going to say it again. We work out the area of one face. One of the faces is a square, and we know the area of a square is side times side. And if the side is x centimeters long, then we know that one face is going to be x times x, which is x squared. Okay, so if I put a number in place there and I said it was the side was 2 centimeters long, it would be 2 times 2, which is 4. 2 squared is 4. Okay, so hopefully that explains it a bit better. And then there's 6 faces, so it must be 6 multiplied by whatever x times x is. And in the example I used, it was 4. So it would have been 6 times 4, which is 24 centimeters squared. Okay. Here's a cuboid that is made up of alternating purple and green centimeter cubes. They want to know what is the surface area of this cuboid. Okay. So the surface area is going to be 2 multiplied by 3 times 4. Okay, and now why 3 times 4? Well, 3 times 4 is going to give you the top and the bottom face. Okay, so you can see the top face is 3 cubes width, 4 cubes long, and there are 2 of them at the top and at the bottom. So therefore, it's 2 times 3 times 4. We need to add to that 2 faces, which are going to be 3 times 5. So if you look at the front and back, it's 3 cubes wide and 5 cubes long. So there are 2 faces like that. And then the left and the right face are going to be 2 times 4 times 5. And you can see that's 4 cubes wide and 5 cubes long. And there are 2 of them. So that's why it's multiplied by 2. We then work out those values. 2 times 3 times 4 is 24. 2 times 3 times 5 is 30. 2 times 4 times 5 is 40. And we add them together, and the total surface area of that cuboid is 94 centimeters squared. They then ask us how much of the surface area is green. Now, if you look at the instruction, it said the cuboid is made from alternate purple and green centimeters cubed. So that means there must be an even number of green and purple cubes. So all we therefore need to do is divide 94 centimeters squared by 2, and the green surface area will be 47 centimeters squared, and the purple surface area will be 47 centimeters squared. If you add 47 and 47, you get 94 centimeters squared. So it's exactly half. Right, now we get onto the surface area of a prism. So this is similar to the area of a compound shape. So remember, when we did area of compound shapes, we would have worked out separate areas and then added them all together. And this is quite similar. So here we need to decide how this L-shaped prism is actually formed. Okay, and you would be quite correct by saying, look, there's 2 L-shaped faces in the front and the back. Okay, the base of the L-shaped prism is going to be a rectangle. The top of the L-shaped prism is a square, because you can see it's 3 by 3. And then there's also right faces that you need to add up. The crucial thing here is to make sure that you work out the surface area of every single face and you do not leave one out. So I suggest that you mark off the faces when you've actually worked out their surface areas. So for this one, there are 6 rectangles that make up the surface of this L shape. Okay, and let's go have a look at how we work that out. So the total surface area is going to be 2 multiplied by 22, plus 18, plus 9, plus 12, plus 6 again, and plus 15. Okay, so what I'm going to do is I'm going to go over to the Google Jamboard and I'm going to show you exactly how we get those figures so that it can be a little bit clearer to you moving forward. So the top face is 3 by 3, so you know that the area of that top square is going to be 9 centimeters squared. Okay, all right, then what I'm going to do is I'm going to have a look. Let's see, I'm going to draw it for you actually. I'm going to have a look at this red face. Okay, and that red face you can see is a length of 4 and a width of 3. Okay, so that's going to give us 4 times 3, and that's going to give us 12 centimeters squared. So we've got 9 there, and we've got 12 there. Okay, let's go work out the surface area of another face. And I'm going to make this face in yellow. So let's work out this face over here. Okay, and again, that's 3 multiplied by 2, okay, and that's going to give us 6, all right, so 3 times 2 equals 6 centimeters squared. Okay, so remember it's 3 because it's the same as this length over here. That's going to be 3, so therefore that's going to be 3, all right, and it's 2 because if that's 5 and that's 3, all right, then this width over here must be equal to 2, okay. Right, the next one I'm going to work out is the front face, okay, and that front face is this face over here that I'm talking about, and again, that's going to be a length of 3, okay, and this length over here is going to be 2, okay, because if this is 4 and this is 6, then this piece over here must be equal to 2, okay. So 3 times 2 again is equal to 6 centimeters squared. All right. So I've done the front face and I've done that step, a little step up. I'm now going to work out the base. Okay, my base is going to be 5 times that length there, which is the same as that 3. So that's 5 times 3 equals 15 centimeters squared. All right. Okay. Now all I'm left is this face, that left face. Okay. And we should be able to work out that that left face is 3 times 6, which is 18 centimeters squared. Okay. And now all that's left for me to work out is the back face and the front face. Okay, and to do that, I'm actually going to cut it in half. I only need to work it out once and then double it. Okay, so this section over here, all right, it's going to be 6 high and 3 wide, which is 18. Okay, that's 18 again. And I need to do this little section over here. Okay, and we've already worked out that that's going to be 2 by 2. So that's equal to 4. So in total, it's going to be 22 centimeters squared. But remember, there's 2 of them. Okay, so there's the back face as well. So that's going to be 44 centimeters squared. Right, now I need to add it all up to see if I've left anything out. So remember, we need to add up to 110. So let's check if I've done it correctly. 9 plus 12 is 21. Plus 6 is 27. Plus another 6 is 33. Plus 15 is 48. 48, I add 18. That gives me 66. 66. And then I add the 44 to that, to 66. And that's going to give me 110 centimeters squared. So happy days. That's how I work out the surface area. So yes, there is quite a lot of calculations involved. However, if you just split it up and take it piece by piece, and as I said, mark off the faces that you've worked out as you've worked them out, then you should be able to calculate the surface area of a compound three-dimensional shape, such as this L-shaped prism in front of you. Okay, it's also useful to know how to use a net to find surface area. So remember, a net is a three-dimensional shape that's been opened up, really. So here's a net for you, and this is the net of a cuboid, and this should make it a lot easier for you to work out, because you can now see the individual two-dimensional shapes that make up the three-dimensional cuboid. All right, so you need to write down the area of each face, so you can see the areas of each face and how to calculate them. So if I just go through them quickly, your 18 centimeters squared is 6 by 3. Your 15 centimeters squared is 5 by 3. The 30 centimeters in the middle is 6 by 5. And then obviously the 30 centimeters on the right hand side is the same, 6 by 5. Then all you need to do is you need to add up those individual areas, and you'll get an answer of 126 centimeters squared. Now, using a net is a lot more straightforward, but you obviously need to know what the net of the specific three-dimensional shape that you're working with is, okay? And that will make it a lot easier for you to understand how to work out the surface area. Here's your last net that I want us to work out. Now, we've already done a lesson on area of triangles, so I would encourage you to go back and have a look at that lesson with online activity and memo, just to brush up and revise and consolidate that specific skill. But the net of a tetrahedron is made up of triangles, and we know that the area of each triangular face is going to be half base times height, or base times height divided by 2. Now we just need to work out what is the height of each triangle, and they've already indicated that to you in the diagram. So the base of a triangle is 6, the height of the triangle is 5.2. All the triangles are equal, they're all the same size. If you work out 6 times 5, you get 30. 6 times 0.2 is 1.2, so 6 times 5.2 is 31.2, and then if you halve that, you get 15.6, and that's the area for one triangle. And I want the surface area for the whole tetrahedron, which is composed of 4 triangles. So your surface area is 4 times 15.6. 4 times 15 is 60. 4 times 0.6 is 2.4. Put them together, you get 62.4 centimeters squared. Guys, that brings us to our finisher and brain challenge, brain bender to finish off on, and it's the game of 24, which I know you guys know pretty well by now. So give it a good go. Remember your order of operations, challenge someone at home, and keep your brain active by doing little calculations like these on a daily basis, and you'll see it'll pay off moving forward in your mathematics classes. Grade 7s, thanks very much for joining me today. I appreciate your time. Please check out the online activity and memo regarding surface areas, and then email me on grade7@worksheetcloud.com should you have any questions, queries, feedback, or anything really, and I'll be happy to address those moving forward. Keep safe, keep well, all the best. Cheers.